Hi, I just wanted to do a short video on the y equals e to the x. So this is on page 314 of your textbooks. You can see here, I've just done a sketch. Here we've got 2 to the x, the black line, and 3 to the x, the black line here. These look exactly the same, apart from 3 to the x will just come further away and 2 to the x will be slightly closer, like further into the axes. And then this is a sketch of what the derivative function looks like. So this is the same for our exponentials. All these exponential functions have this nice property where when you look at the function itself and then when you look at the derivative of the function at any point, they have a really similar shape. When you look at 2 to the x, the derivative function is slightly below, and then for 3 to the x it's slightly above. And what this tells me is somewhere in between 2 and 3, as this moves up and as this moves down, you're going to kind of get that sweet spot where the derivative function is equal to the function itself. And this is what happens at this number e. So when we have e to the x, this function, the derivative function is exactly the same, and these two lines will lie on top of each other. I have a feeling some of you might be listening to this and be tempted to ask, oh, but why does he have this property? You can prove it from first principles, however it's a difficult thing to do. It's not nice like when we were doing first principles earlier on in the textbook. What I would recommend is, if you are curious, to go onto YouTube and just put in derivative of e to the x or proof for derivative of e to the x. There are plenty of videos that explain it, but it is a difficult concept to get your head around. All you need to know for your A-level course is that the derivative of e to the x is e to the x, and we will use this over and over again. We can then go a little bit further and start differentiating things that are slightly harder. I say slightly harder, not really, but if I look at f of x is e to the 2x, the derivative of this function here, f dash of x, my e to the x, this will stay being e to the 2x, the same as when we differentiate e to the x, we get e to the x. But what I'm going to have to do is I have to multiply by the 2 here. So because this number here is 2, this comes down in front. This is an extension of the chain rule. What you're actually doing is you're differentiating your e function, and then you're multiplying by the derivative of this here. So because the derivative of 2x is 2, I multiply by the 2. But that's getting slightly more complex. If you want a little bit of reading, the chain rule is in the second book under differentiation, so you can start having a look at that if you feel like it. But right now all we're going to do is things where we've got k, some number here. So again, if I had f of x is e to the 3x, then equally the derivative of this is going to be 3e to the 3x. So the power here always stays the same, and you just multiply by this number, this comes in front. And then that's as tricky as it gets. I think that's all you need to know for now. If you read through example 3 and example 4, example 3 shows you some derivatives just like this, and then example 4 does some transformations. If you were able to transform your other exponential functions in the previous section, then you should be fine with transforming these. All it is if you wanted to, say, sketch this e to the 2x, then if f of x was e to the x, and then I wanted to sketch e to the 2x, then this 2 here is being applied to my x before I apply my function. So this is going to be inside the brackets, f of 2x. And so here I can see this is going to be a stretch horizontally. Sorry, not horizontally. Yeah, horizontally. In my x direction. So I'm stretching this way, and then I'm going to stretch by a factor of a half because we're inside the brackets. So everything's going to shrink in like this. Yeah, and then the same thing if I wanted to do something like add 1. Then this would be f of 2x plus 1, and then this thing here would mean I've got shifting up 1 as well, and so on. Okay, thank you very much for your time, everyone.